right, everybody, week 7. We're going to take a look at number 3. Okay, the age and years of 6 employees at a particular computer store are the following. Okay, so we have a 23-year-old, 34, 29, 46, 40, and 44. All right, so assume this is the entire population, which means it's everybody working at this store. They want us to find the standard deviation of the population. Okay, so standard deviation of a population looks like that. Round your answer to 2 decimal places. Okay, so I'm going to assume that we don't have the graphing calculators that will do this for you. I'm going to do it old school by hand. So the first thing we're going to do, step 1, is we're going to find the average. Ages. Okay, so you're going to add 23 plus 34 plus 29, 46 plus 40 plus 44, and then you're going to divide that by 6, right? 1, 2, 3, 4, 5, 6. Okay, so when we go to find our average, which is mu when we're working with population, our average age, let's see here, if I add this up, divided by 6 is 36 years old. Okay, deviation means how far away have these ages deviated from the mean, right? Now, not everybody is 36 years old. You have people that are older than 36. You have people that are younger than 36. So we're looking for what's the deviation in general. Okay, so step 2 would be you're going to take each of these ages and you're going to subtract away the average, right? So we're going to set this up. We're going to take each of these data points and subtract the average. So 46 minus 36. Okay, so what we're going to do is get those averages, and then we're going to square them. And that's finding variance. And once we have the variance, we take the square root of that, and that is our deviation. So don't get overwhelmed. We're just looking for, how far away did each of these ages get from the average age. So we're going to do 23 minus 36, negative 13. Now, if you square negative 13, right, negative 13 times negative 13 is going to give you 169. Okay. And then 34 minus 36, we're going to have negative 2. And if you square negative 2, that's 4. All right, 29 minus 36, that's negative 7. So these are all negative because these ages are younger than the average. If you square negative 7, it's 49. Anytime you square, you should end up with positive answers, right? So even though our distance away from the mean is negative, because these are younger people, when you take and you square a negative, you should get a positive, because a negative times a negative, of course, makes a positive. Okay, 46 minus 36 is 10. 10 squared is 100. 40 minus 36 is going to be 4. 4 squared is 16. And then we have 44 minus 36, and that's 8. And 8 squared is 64. Now you want to add up your squared distances from the mean. So 169 and 4 and 49 and 116 and 64. It's going to bring us to 402. Okay, so once you do that, you're going to divide by the number of pieces of data, which is 6. That's going to give us 67. And then you're just going to take the square root of 67. So if you take the square root of 67, the deviation is roughly, now they're telling us to go out, 2 decimal places? So it's 8, let's give myself some room, 0.18 on my calculator, 185. So if we want to go out 2 decimal places, we want to throw up a door. That 5 tells that 8 to go up. So roughly our standard deviation of our population is 8.19 years. That's roughly how far these ages deviate or stray from the average age of 36 years old. All right, hope that helps. Bye.